Alright, this is AP Stats, section 9.3, part 1. We're dealing with sample means in this video, and particularly we're going to do some examples just of approximating a population with X bar in this video. Last section we saw sample proportions approximated by the normal curve when the sample was less than 10% of the population size. That was rule of thumb number 1. This time we're going to see that same thing with sample means. Sample proportions usually come from categorical variables. We saw that done with something like the number of people that go to church was one example we did. Means come from quantitative variables, things like income, lifetime of a brake pad, numbers. The sampling distribution of X bar is the distribution of the values of X bar in all possible samples of the same size from the population. Again, just like proportions, we're not looking at one proportion, we're looking at an infinite number of proportions from an infinite number of samples and looking at all those together. When we look at all those together, that's when they become normal. Here's the behavior of X bar in repeated samples. These are going to be similar to what we saw with proportions. In repeated samples, the sample mean, X bar, is an unbiased estimator of the population mean, mu. Number 2, the values of X bar are less spread out for larger samples. They have a smaller standard deviation. Their standard deviation decreases at a rate of square root of n. So a sample must be 4 times larger to be half a spread, because 2 would be the square root of 4. And the third behavior of X bar, you can only use the formula for standard deviation of sample means if the population is at least 10 times larger than the population. I wrote that wrong. You only use the formula for standard deviation of sample means if the population is at least 10 times larger than the sample that we're dealing with. That's the same rule of thumb number 1 that we dealt with last section. Again, at the end there should be, let me just do that. Alright, got that fixed. You can only use the formula for standard deviation of sample means if the population is at least 10 times larger than the sample of interest that we're looking at. Alright, let's end this video with a little example about young women's heights. We're going to find the probabilities involving the sample mean. The height of young women follows a normal distribution with a mean mu of 64.5 inches and a standard deviation of 2.5 inches. We're going to find the probability that a randomly selected young woman is taller than 66.5. This is going to be normal again, so we can use our normal distribution. First thing we have to do is standardize this value. The mean I told you was 64.5. We're looking at the probability of 66.5. That's going to be our x for our random variable. We'll get a z-score, do 66.5 minus 64.5 over the standard deviation they told us was 2.5. That z-score will be 0.8. When we go to table A, that's going to tell us less than, so actually we need 1 minus the value from table A. The value from table A was 0.7881. So when we do 1 minus that, so we can have the greater than side, we get that probability to be 0.2119. Again, we didn't do anything dealing with the sample size in this one. We just treated it normal, because they told us at the top that the height of young women was normal, and we were just getting the probability of any randomly selected woman, not dealing with sample size yet. We'll finish this with sample size in the next video. Alright, for part B, they want us to find the probability that x exceeds 66.5 from a SRS with n equals 10. First thing we need to do if we're going to use the formula we need to know if we're going to use the formula for standard deviation. We need to think, would the population of young girls be more than 100? They didn't give us exact context on this, but you have to assume yes. So we can use our formula. So we know the standard deviation of x bar is equal to standard deviation of the population divided by square root of n. Standard deviation of the population was 2.5. Square root of n would be square root of 10, leaving us with the standard deviation of this sample to be 0.79. Now we can use that 0.79 to go and find the probability of the mean height of this sample of 10 women, using the normal distribution again because of rule of thumb number 1 that our population was at least 100. So now we know that we have a normal distribution. Our mean is still 64.5, that was given. Now we're dealing with a standard deviation of 0.79, which we just looked at. Let's standardize our value. Let's get a z-score. We're looking at exceeding 66.5 minus the mean 64.5 over our standard deviation 0.79. This z-score is 2.53. When you go to look that up in Table A, again, Table A is giving you less than. Table A gives you 0.9943 is the probability that the mean of these 10 girls would be there. It would be less than that. We need the probability again that x is greater than 66.5. Mercy. That's going to be 1 minus 0.9943 or 0.0057. So not even a whole percent, half of a percent of likelihood that the true mean is, what color? The true mean is 64.5 that of the population, that you would get a sample with a mean size of 66.5. The chances of that happening are half of a percent. Not very likely.